Hello, this is Mr. Wilford, and I'm going to take a look here at Chapter 6, Section 1. We are beginning a new chapter here. We are talking about polygons in this chapter, and in Section 1 here, we're going to start out talking about the properties and attributes of polygons. And so what we're doing now is really we're kind of working from things like a triangle into a polygon where we have many sides to it. And so we want to make sure that we take a look at some of the terminology and things like this dealing with polygons. You can see here in this nice little chart a polygon. Well, there are several. A triangle is considered a polygon. And the number of sides it has is 3, and then we have a quadrilateral, which has 4 sides, pentagon, which has 5, and so on. You can kind of read through here. According to the number of sides, the names of that polygon. So we have our sides of a polygon in this diagram. We have our vertex points, vertex points of a polygon. And usually we label those with a letter, capital letter A, B, C, and so forth. And then we have our diagonals of a polygon where we go from one vertex to another. And so those are some of the things that we're looking at here in this chapter. So in the beginning here, we're really just talking about what is a polygon and what is not. You can see here in these examples, these are some pretty good examples. We have a polygon. This is a pentagon. Here we do not have a polygon because it's we have really 2 triangles put together. And this is a polygon here, even though it looks kind of like a weird shape here, but it's still considered a polygon. Actually, it's an octagon because we would count the number of sides, and we have 8. And so, really just deciding whether something is a polygon or not is the beginning of this section. And then this is an important term here. A regular polygon is one that is both equilateral and equiangular. If a polygon is not a regular polygon, then it is called irregular. So we'll look at some regular polygons. A polygon is concave if any part of the diagonal contains points in the interior in the exterior of the polygon. So if, for example, this is a concave quadrilateral because we can draw this diagonal here from this vertex to that one, and that would be outside of the figure. A convex polygon would be something like this, where we draw our diagonals and we actually have the diagonal lines inside the quadrilateral or the polygon. So now we're deciding here whether we have a regular or irregular, and then concave or convex kind of polygon. The first 2 are convex. The first, this is just a rectangle. This is irregular. Notice that these 2 sides are the same, but these 2 sides are different. Here we have a regular convex polygon. And then here we have an irregular and concave. And again, concave means that if I draw a diagonal from this vertex to that vertex, it's outside of the geometric figure. Okay, now what we want to be able to do here is talk about the sum of the measures of the angles, of the interior angles. So as we add up the angles of a triangle, we talked about that as being 180 degrees. In a quadrilateral, where we have 4 sides, it is going to be 360 degrees. And a pentagon is going to be 540 degrees, and so on. You can see that each time we are multiplying 180 times this number here, which is going to be n minus 2, the number of sides minus 2. And that gives us a polygon angle sum theorem. So the sum of an interior angle measures the convex polygon is n minus 2 times 180. So you'll have to look through a few examples here and dealing with some of those theorems and some of the different polygons. Here is a polygon exterior sum, and that's 360. So again, just take a look. If you have any questions, please let me know. Thanks.